Okay, CL Prep Geometry. This is 2.2. This is the homework from Friday 9:30 from Wednesday 9:30 due Friday October 2nd. And let's just jump right into it because I'm going to try to do this in one video. So 2.2 is about, section 2.2 is about inductive and deductive reasoning. Let's explain to you what those are. Those are the two main categories of reasoning. So it's two like completely different branches of how you make an argument, is inductive and deductive. And write those down in the blanks so that when you write them down, that it helps cement it in your brain. You might say, not much, Mr. Rollinger, well, it's doing something and it's getting the process rolling. So what is the difference between inductive and deductive? Inductive is starting from data and examples and going to guesses and conclusions. Right? So you start with just some data, and then you go, I think this is true, and that's good. That's inductive reasoning. Deductive is starting from formal principles, and instead of using data, it's using formal principles and using logic to say conclusions that must be true. So data and examples, in inductive reasoning, you're using kind of your guess based on patterns. So I could put that down, patterns. We're going to use that word again in a second. Whereas deductive reasoning operates on logic. Okay. All right. So let's come with me. There we go. Okay, close enough. Let's go to some examples. So inductive reasoning. So you start again with data. And you notice a pattern somewhere in that data. You know, you look at the data and you go, we've noticed something. And this causes you to make, okay, here's a new word, conjecture. A conjecture is just an educated guess. Guess based on data. So it's not just a wild guess. It's like I've looked at the data and I've got this conjecture. So, for example, here's an example they can use for this. Scientists had this information: is that they had no young people. Sorry to bring up masks and virus, but it's a good example. No young people died of the virus, right? They looked at that and they were like, everybody who's dying is old, right? And then, so they know, and also, or you could also bring the pre-existing condition. Everybody who's dying had a pre-existing condition, right? And so they noticed that. So they noticed that they had the information on what they noticed that age determined whether it was lethal. That was like the pattern they noticed. Whether it could be really dangerous to somebody or not was just totally based on age. And so they made a conjecture looking at it, which was that only older people need to worry. All right, I mean, we can talk about spreading it and stuff, but in terms of for your own health. Right? Now you can say the scientists were wrong, and scientists who made this conclusion would have been wrong. But the thing is that's the problem with inductive reasoning. Like, you've got the data you have, and you're making your educated guess based on the data. So they made a conjecture that it seems like, seems like you're going to be okay if you're young. And then more data came in, and then it was like, okay, now we have to amend that. We have to change that, and we have to say, no, you got a better chance of being okay if you're young. But some young people are still going to get pretty sick from this thing. And so when you get down on scientists, when you're like, oh, they got it wrong, it's like, well, science always gets things wrong. I mean, they make the best guess they have with the data they have, but then they're open to the possibility that we'll get new data that might cause us to change our conclusions. That's the way science works. And that's the way all the scientific benefits that you see around you and all the things we know, that's why we're able to have all that stuff, is because people make educated guesses based on data. And then maybe they had to change them over time. They're like, oh, we had something wrong. Here's the new information. And you just have to know that it wasn't that they were dumb. It was that they just didn't have the data yet that showed them that they were wrong. So, whoa, there we go. So inductive reasoning holds as long as the pattern does. So as long as the pattern stays true, you go, yeah, it looks like this thing's working and we're right about this. But once you find a counterexample, that's another vocab word. I better write that better. Are you going to erase? Now you don't want to erase. Okay, so that's counter, example. Once you find a counterexample, then you know your conjecture is false. And until you do, you can have some confidence and getting more confidence that you're right, but you know that if a counterexample shows up, you're going to be wrong. So, for example, take a prime number and multiply it by 2 and add 1. The result is prime. I'll show you. So you take 2, double 2 is 4, plus 1 is 5. And that's prime. 3 times 2 plus 1, that's 7. Prime. 5 times 2 plus 1, 11. Prime. See how this works? Are you convinced? Because then you go to 7 times 2 plus 1, and you go 15, and it's not prime. No, didn't work out. Up until that point, we had some evidence, and we only plugged in 3 numbers. So we'd want to test it a little more, right, and get some more data to be more confident about our conjecture. But up until this point right here, we were like, yeah, this thing looks pretty good. But then we came up with a counterexample. We go, oh, yeah, okay, that's wrong. So what we said wasn't true. And we thought we had some truth. We had gotten some truth, but a counterexample showed that we were wrong about it. So what inductive reasoning is used for? It's used for science. It's the basis of science, is that starting from data, making conclusions, and then testing them out and seeing if they stay true. That is what science is fundamentally based on. Right? Okay, so that's inductive reasoning, and it's really important. Even if you look at it and you go, yeah, but it's wrong sometimes. Yeah, but we'll make our best guesses, and it's better to make educated guesses and be thoughtful about it than to just assume you're right and keep your eyes closed and not look at what the data is showing you. Okay, sorry that my writing is having trouble scrolling here. Okay, so now deductive reasoning. So what's that again? Remember that's starting from principles and going to conclusions. But the way we do that is that we use logic. Use logic instead. So, for example, everyone who attends Seattle Prep is transformed, so they bleed blue and white. My son went to Seattle Prep, so that means he must bleed blue and white, literally. Okay? So the premises are that if I'll just write if SP, meaning if you attended SP, then blue and white. I'm abbreviating it a little bit, but you see which part of it goes in which spot, so it's okay to abbreviate, like in homework and stuff like that. And then we know my son went to Seattle Prep, so SP is true. Right? The conclusion then is my son bleeds blue and white. It's true for my son, I guess I should say, for my son. Like that a little better. Okay, now there's a little bit of a difference between an argument being valid. I can't erase that, sorry. I don't know why my eraser's not working right now. I don't get it. Okay, moving on. So there's a little bit of a difference between an argument being valid and sound. The book doesn't talk about this, but I think it's a really good thing to know about, and it's probably from my philosophy degree that I think it's important for people to do this. So what's the difference between being valid and sound? Valid means the structure is okay. Structure is okay, but the premises may be false. And sound means structure and premises are both good. So suppose you accepted that the premises were true. If you go to Seattle Prep, you literally bleed blue and white afterwards, and my son went to Seattle Prep. You accept those things as being true. does the conclusion then follow that my son must bleed blue and white? And I'd say, well, yeah. I mean, if everybody who goes to CL Prep will then bleed blue and white, then my son did go here, then if those two things are true, then yeah, I guess he must bleed blue and white. So the answer is yes. It's a valid argument, meaning if you accept the premises to be true, the conclusion has to be true. But is it sound? And it's like, I don't think that's true, that if you attend CL Prep, then afterwards blue and white will come out of your veins. I don't think that's true. So the structure is fine and the argument is fine, but the premises have a problem with it. And you can question the premises. So is it sound? No, because premise one is funny but not true. Okay? So as long as you've got a valid argument, then if the premises are true, the conclusion must be true. But to have a sound argument, you have to prove that those premises actually are true. You have to like make sure that nobody can question them. Now there's two deductive laws you're going to learn. Whoa, come back, stay with it. There we go. There's two. Having trouble today. There's two deductive laws that you need to know about that are different structures that you can use. So I'll show you what those structures are. The first one is called the law of detachment. And here's what it is. It's if A, then B. So I want to make it the basic structure without any examples in there. So if something, then something. So in our example before, we started with if you attended CL Prep, then you bleed blue and white, right? So A is kind of attending CL Prep, and B is bleeding blue and white. And then A is true. So my son attended CL Prep. So these are your premises, premise one, premise two, and the conclusion is that B must be true. So this is one way you can make an argument. You can say, will you accept that if this, then that? And they say, yeah, I'll accept that. And you say, all right, I'm going to show that this first thing is true. Then you have to accept the second one is true. That's an example of law of detachment. And we'll look at some examples in class on Friday. Okay? So I hope looking at the blue and white example, you can go, oh, okay, yeah, that makes sense. That structure is valid. It doesn't mean it's sound. You actually have to prove that the premises are really true, and not, I'm not just making something up. The second deductive argument law, and this is the last thing, is called the law of syllogism. This is what a syllogism is. If you probably haven't heard that word, but I mean, I watched some videos where people use the word. Okay, so premise one is if A, then B. Okay. Premise two is if B, then C. And now, what is the conclusion you can make? So if A is true, you know B is true. And if B is true, then you know C is true. What conclusion can you make? It's not just that something's true, it's an if-then statement. It's a conditional statement. It's, okay, the result is if A is true, then C is true. This is the kind of thing I often call this the law of anxious worry. The whole thing of well, if I do bad on this test, then I'll have bad grade on this class. And if I have bad grade in this class, then I won't get into college. So that means if I do bad on this test, then I'm not going to go to college. Where you make this chain of disasters and say, if this happens, then this is going to happen. And if this happens, then this is going to happen. And so that means this one moment now suddenly is going to determine everything for the rest of my life. Obviously, we don't want to go with that. And you can question some of those premises and say, is that really true? If you have one bad grade, are you not going to get into college? Really? And which is not true. But But the structure is totally makes sense. If you know the first thing is true, then the last thing has to be true. Okay, I'm going to stop it right there. So that is the notes for 2.2, and come ready on Friday to be able to use this, and we'll practice.